Hi students, let's learn about naming benzene compounds. Before we begin, we must know what is benzene. Why is there a need to name something differently? Okay, so far what you have learned is naming cyclic compounds. So let's say I give you a cyclohexane. So you should know this before you continue this lesson, that if I have 6 carbons connected in a cycle, then we can simply call it cyclohexane, right? Now, if there is a double bond in there, we call it cyclohexene. Let's say there is a double bond anywhere along that cycle. Doesn't matter where it is, wherever that double bond is, that gets the priority in naming. So you will call this cyclohexene, because there is a double bond somewhere along that. Now, if there's more than one double bond, then we need to refer to the location of that double bond. So let's say I have a cyclohexene, but this time I have a double bond here and a double bond here. Okay, so in this case, what we need to do is we need to give it a numbering such that we get the lowest numbers possible. Doesn't matter which double bond you begin with, but when you start numbering, you know you have to go over the bond. So 1, 2, 3, 4, 5, 6. If I started here, it would be the same numbers, 1, 2, 3, 4. Okay, if I started here, 1, 2, 3, 4. Here, 1, 2, 3, 4. So there's no other way you could have numbered it and gotten a different answer. So the first position and the fourth position has the double bond. So what we call it is there's the old method where you would first refer to the numbering, but the best way to do it is to do cyclohex 1,4 diene. Okay, so that 1,4 represents the first position and the fourth position, and the di represents that there are 2 double bonds. Okay, 1,4 diene. Ene represents the double bonds. So you have a cyclohex with 1,4 diene. Now, if you can have 2 double bonds, you can also have 3 double bonds. Okay, this is where the structure kind of becomes useful, where if you draw the complete structure, you can see the possibilities. Okay, so let me draw the complete structure here. Carbon, carbon, carbon. So you see in this structure, each carbon has only 2 possible bonds left. This carbon already has 2 bonds. Maximum bonds it can make is 4. So you can attach 2 more things to it, right? So when I do a double bond here, this carbon now has 1, 2, 3 bonds. You could do another bond here, but that makes this very unstable. It turns out that we are drawing this on a very large scale. In reality, this is very small compounds you can't even see. So you cannot place a double bond there. Turns out that if you place a double bond here, it would, now this is more complex chemistry that you don't need to be worried about, but basically that bond jumps to the other carbons. Okay, and same here, you cannot place a bond here, you have to place it here. So this double bond that we are placing, turns out that you can only place them on alternating carbons. Okay, and then when we do a spectrometer analysis on this, so spectrometry is when you bombard any compound with light, and you can detect what kinds of bonds it has depending on the data we have from known compounds. Let's say if I know that I have a carbon-carbon double bonded ethene, then what kind of graph does it generate? So it turns out that this compound actually does not generate any graph that represents a double bond, even though it has 3 double bonds. Okay, so ideally I can draw this theoretically, and I would have to name it. Let's say if I start from this carbon, 1, 2, 3, 4, 5, 6. So on the first, third, and fifth carbon, I have double bonds. So I can call it cyclohexene 1,3,5 triene. Right? That's a very valid name, and that's a very valid structure. Turns out in reality, this structure does not exist. In reality, what happens is that these double bonds, because as I said, they are very unstable, it's such a small compound that those bonds, when you have a bond on one place, it jumps over to the other one, and then because of that, the other bond jumps over, the other bond jumps over. This is called a resonance structure, which you will learn at a later stage in higher studies in chemistry. But basically, when we detect this, it's like we are detecting 1.5 bonds. Okay, so instead of detecting 3 double bonds, it's like we are detecting 1.5 bonds. Okay. What does all this mean for naming? Well, all it means is that now we cannot call this cyclohex 1,3,5 triene because it is not that. Okay, so we have represented it using something different. What we have decided to do, you can represent it like this, and you will find it like that in some places, but mostly we represent it with a ring in the middle. So that ring represents that those bonds are always moving within it. Okay, and because of this characteristic, these compounds get very unique properties. Okay, we call them aromatic compounds because they release not aroma but smell. You can detect that smell. It's that potent. Okay, so they're called aromatic because of, not because of their good smell, but because of their bad smell. Another thing on that structure that we just drew, if you look at each carbon, it will have only one more possibility for a bond. Okay, so that one more possibility could be hydrogen in a normal situation, or it could be anything else. Okay, so this structure, whenever you see this, we have 3 double bonds in a cyclohex. We have decided to call it benzene. Okay, this is benzene. It is no longer a cyclohexene, it's a benzene ring. And on that benzene ring, on every carbon you can have something attached. For that, the rules remain the same as before for cyclic compounds. For example, if I have a benzene ring and I have a ethyl group attached there, or if I have a chlorine attached here, okay, let's say this is my compound, then how I'm going to name it is I'm going to start with numbering priority. In terms of numbering, ethyl gets the priority 1, 2, 3, 4, 5, 6. In naming, alphabetical order, so 2-chloro, 1-ethyl, benzene, no space. Just like instead, if this was a cyclohexane, you would write cyclohexane. Here you write benzene instead because of that ring, or because of the 3 double bonds that you would see. Okay, it's as simple as that. Everything else remains the same, just that the last name now turns benzene. You can also have benzene as a side group in some cases. Okay, if you have a really long chain of carbons, and then you have benzene as a side group, let's say somewhere here, this is also possible. Okay, when that happens, benzene is written as a side group. So here on the 3rd position on these 9 carbon, on this 9 carbon chain, it will be written as phenyl. Okay, just like a long chain of carbons as a side group. If you remember, this is -il ending, right? Ethyl instead of ethane. Benzene, instead of writing it as benzene as side group, we name it as phenyl. Okay, phenyl, when you see that, that means it's benzene as a side group. So in this case, we would call it 3-phenyl, 3-phenyl, and 9 carbons, all single bonded carbons. So this would be nonane. Okay, 3-phenyl nonane. So these are the only two new things you need to be worried about in terms of naming. Benzene, and it as side group is phenyl. Okay, try all the practice problems and let me know if you have any questions.